Okay, I'm attempting the easiest integral on dailyintegral.com, the beginner integral for today, and that looks like this. But a simple thing to do here would be to just have, well, it's 1/2 ln of whatever is in there, so we probably would just say, okay, we're going to move that out, and then just have that, okay, as this to the exponent of 1/2. But we do need to make sure that the stuff in the the stuff in the natural log is positive, but that should be okay because it's 1 minus sine squared, and sine squared, the maximum it could be is 1. And so if you have 1 minus 1, that's still 0. 1 minus cosine squared, still the same thing. 1 minus 1 would be 0. And obviously we don't want a 0 down here, but I don't think it would actually ever happen because the bounds are pi over 4, it's pi over 2, and cosine would only actually be 0. Yeah, it would only actually be 0 at pi over 4. Yeah, because cosine is something like, right, so say it's 0, and yeah, so there's pi over 2 and pi over 4. Oops, yeah, pi over 4 here, pi over 2 here. So here it is 0, but that's honestly fine, doesn't really matter. But so we're looking at this interval, and it's not 0, and we're taking the cosine squared, so this is actually going to be like somewhere up here, which is positive, so that's fine. So this, we can just say, yeah, it's that. So we'd say pi over 2, pi over 4, 1 minus sine squared x over 1 minus cosine squared x, and the root of that. Okay, okay, the best thing I think would be just to turn this bottom part into a sine squared, because, yeah, 1 minus cosine squared is equal to sine squared x, because sine squared, well, yeah, we could also say sine squared x plus cosine squared x is equal to 1. Well, okay, so anyway, we have, say, 1 minus sine squared x over sine squared x dx, and that then is going to be also quite simple to think about, because we will just separate this part, this into 2 fractions, because I think that's an easy way to integrate this, I think. And we can kind of get rid of the square root sign in just a moment, we'll see. So say sine squared x as the root of that, and we can see here it's going to just be negative sine squared x over sine squared x, which we would say it's 1 minus 1, and it's the square root of 1. Oops, no, that's wrong. Okay, yeah, no, this is not how you would do it. You probably just use cosine squared up here. Okay, so we would probably just turn this into a tan, actually. A tangent or a cotangent. Yeah, a tangent. Well, cotangent. So yeah, it's the root of 1 minus sine squared x, which says cosine x squared x, and bottom is sine squared x, as we were talking about just now. And so, yeah, just take the root of both of them. They're both going to be positive, so it doesn't really matter that much. And yeah, okay, yeah, so sine squared cosine. And so that should just be the integral of tangent right here. So integral of tangent is secant squared, I think. At least I think. So it's gonna be here secant squared x pi over 2 pi over 4 equals, what is that? Yep, so we just say secant squared pi over 2 minus secant squared pi over 4, which is, okay, I guess we'll just try to actually solve this normally, by hand. 1 over cosine squared pi over 2, which actually, okay, and minus 1 over cosine squared pi over 4. Ooh. Which might be a problem because that looks like 0. Okay, anyway, 1 over, yeah, cosine pi over 2, which says 1 minus 1 over cosine squared pi over 4. Now, oh, okay, I see what I did here. I forgot to make this negative 110 to 1 over 10. And actually, I think we should have just kept it in this form, where we have cosine x over sine x dx. Because then we can just use substitution, say let u, for example, equal sine x, and u dx would be then, what would that be? Sine x, so cosine x. I don't think it's negative, I think it's just cosine x. I can never remember, actually. Yeah, cosine x, so then we don't have to write this out explicitly, but we would say it's 1 over cosine x du is equal to dx, so we can put that in here, and we would get out of there pi over 2, pi over 4, keep the bounds out. Actually, we need to change the bounds in a second. We'll do that in a second. Yeah, so cosine x, sine x, which we've actually said this is just u, times 1 over cosine x du, and the bounds here, we sub pi over 2 into sine x, so yeah, we'd say, yeah, sine x is like something like that, right? So yeah, pi over 2, we just say 0, and here pi over 4 is 1, right? Yeah, so now that just looks like, I guess we could flip it around and say negative 1 to 0 of just 1 over u du, which is a simple integral, because that should just be the natural log, unless I'm forgetting. I think it is. Okay, we'll just go with that. I think this is the natural log. So negative of, yep, ln u, 1 and 0. So we would say negative ln 1 minus ln 0. Can we take the natural log of 0? Is that a thing? No, we can't. Darn. Okay. I've realized what the mistake was. This is wrong. Sine pi over 4 is not 1. Sine pi over 2 is not 0, of course. Sine pi over 2 is 1, and sine pi over 4 is, I think, like root 2 over 2 or something like that. Yeah, opposite. Yeah. Okay. Yeah, root 2 over 2 because it's 1, 1, root 2. Yeah. Okay. Yeah, so this was never 1 and 0. This should have been 1, and this should have been root 2 over 2. So we can get rid of the negative sign there, actually, because that's 1 root 2 over 2. And so it's ln 1 minus ln root 2 over 2. It should be this. Let's check. Yep. This is the correct answer to this question here. That's definitely an easy integral, basic integral. If you remember this correctly. If you remember the sine graph, sine and cosine graphs, and also if you don't make a few silly mistakes like this here with forgetting that this is a cosine over sine instead of sine over cosine. Well, okay, anyway, that's it. That was the easiest integral. And it should have been easy.